Hello and welcome back to Special Relativity. In these last lessons we're exploring some paradoxes in relativity.
The encounter could create a time paradox, the results of which could cause a chain reaction that would unravel the very fabric of the space-time continuum and destroy the entire universe.
Let's talk about the paradox of the spaceships now. Consider two spaceships that are moving in opposite directions as seen by you. Rose is moving to the right and Jack is moving to the left. The relative speed is beta. Both are at the front side of the spaceships. When Rose passes the engines of Jack's ship, she gets scared and pushes unintentionally the rear missiles button. Then one missile is launched to hit Jack's ship. From Rose's frame, because Jack is moving and his spaceship is contracted, there is no impact. From Jack's frame, because Rose is moving and her spaceship is contracted, his spaceship is at range and there is an impact. Is there or is there not an impact? What do you think? What did I miss? Because you know that there can't be any paradox in relativity. There has to be something I didn't account for, or some assumption I made that I shouldn't have. You've got it? Yes, of course, the speed of light. If Rose hits the button that launches the missile from the rear of the spaceship, then the signals from the button to the missile needs some time to reach, right? While the signal is traveling, the spaceship is also moving. Let's do some calculations. Let's start with the reference frame of Rose. Here we have again a race between a light signal that is going to tell the missile to fire and Jack's spaceship. The signal moves to the left and Jack's ship also to the left. I'll consider the nose of Jack's ship and the light signal. I want to know which one will arrive first to the rear of Rose's ship. If it's the signal, the missile is launched before Jack is at range. If it's the nose of Jack's ship, then he will be at range. The position of the light signal is CT, and the position of the nose of Jack's ship is L0 over gamma, because of length contraction of his ship, plus VT, the distance traveled. I solve this system of equations to find the position where they meet. If they meet at a distance smaller than L0, everything's fine. This means that the light signal passes Jack's ship. Well, this result is greater than 1. This means that they would meet at a distance larger than L0. This means that when the signal reaches the missile, Jack's ship is in range. If the ship is traveling faster, this means that its length will be shorter because of length contraction, but will be traveling faster. If beta is smaller, it means that it travels slower, but the distance to make is shorter. In both cases, Jack's spaceship is impacted.
Termination of Captain Jack Harkness in under 2 minutes, 100% probability.
What about Jack's frame? From his perspective, Rose's ship is contracted and moving. Could it happen that while the signal is traveling to the rear of the ship, Rose's ship gets out of range to hit Jack's? Well, it doesn't seem like possible. If you look at the rear part of Rose's ship, that part is traveling to the right at V and the signal of the missile is traveling to the left at C. They will meet at some point at range to hit Jack. Too bad. This paradox ends with a nasty impact on one of the ships. Or should I say, lack of paradox.
Close the door, will you? Your ship's about to blow up. There's going to be a draft.